All right, folks. Today I'm going to take you through drawing your traverse in lab and extracting coordinates and aerometrics from your points. Before you get started, you want to make sure that you have a nice table made showing your elevations for each point by foresight and also your horizontal distances from your foresights. This was due, the calculations were due at the start of this lab, and you're going to want to take that and put it into Excel or Google Sheets as a group and make sure it's shared with everybody because that's the information you're going to need to do your drawing today. Once you've done that, you're going to open up Civil 3D as a reminder from the CEE software folder on the desktop. We always choose Imperial because we're going to stay in feet and you're going to log in. And this is a computer I've used before, so I'm already logged in. Go ahead and pause this video if you haven't done those things and you need to do them. And you can pick back up when you are ready. If you are logged in and you have all of the information you need, you're going to click on New, and we are starting a new drawing. So as a reminder, if you prefer to follow the step-by-step guide that I have written out, you can do that. You can also watch this video, whatever you find more helpful. So first thing we're going to do is we're going to save, and we're going to save to our desktop. And I am going to go over here and make a new folder, and I'm going to call it Project 1. And I am going to call this by my last name, Traverse. Everyone needs to hand in a traverse today. I want to make sure everybody is capable and comfortable drawing traverses. So for the first time ever, we care about where our drawing is placed in Civil 3D. This is because we are dealing with coordinates today. So one of the first things we're going to have you do is pay attention over here to Tool Space. Tool Space has all of these little side tabs that we're going to start using more and more as we make our way into the land development section of this class. Prospector has some cool functions in terms of topography that we'll deal with for our next project. What we care about today is settings. So you want to find Tool Space, you want to click on Settings, and then you want to right-click on the name of your drawing and say, Edit Drawing Settings. And when you do that, you're going to get a pop-up window with all sorts of information. The first tab is Units and Zone. Again, that sort of tells us where we are. I want to point out some things. We're drawing in feet. Our angular units are degrees. We could set them to grads or radians, but we are not evil, so we won't do that. Imperial to metric conversion is something you have seen before. We have our international foot that we're going to stay in. 1 foot equals 0.3048 meters. But you could also, if you were in a state that uses the US survey foot definition, use that definition in this setup. We won't talk as much about scale today, but scale is something we'll deal with later. Today, we want to tell Civil 3D what coordinate system we are in based on our location. So you're going to scroll down and you're going to find USA, Pennsylvania. And I want to bring up Chrome real fast, and I might try to share to that. We have a couple of options here. In Pennsylvania, we have a bunch of different zones that we can use. We want to use NAD 83. As you remember, that is our vertical datum. The question is, are we north zone or south zone? We're obviously going to be US feet because we are in surveying class. So what I would say, let me see if I can pull this up. Pennsylvania State Plane Coordinate System. So I am going to share over here. Pennsylvania has what we call the State Plane Coordinate System. So this is a way that we turn all states into a grid. Pennsylvania, because it is extremely large, has 2 different zones, the North and the South zone. And if you know what Northampton County looks like, we are this county right here, meaning that we are in the South zone. Again, if you are doing this type of work for a company, you always want to check what zone you are in, no matter what state you are located in. So I'm going to come back over to Civil 3D. And now I know I want NAD 83 South Zone. I can either do meters or feet. We are using feet. All right. So we're going to say apply. Don't say OK yet. And then I want to go over to ambient settings. And this allows me to specify the precision associated with my measurements. I want to find angle, and I want my units to be in degrees. That's good. Let's look at some of our other options. We could have rounding decisions. And our format is what we want to change. Instead of decimals, oh, excuse me, I sneeze. Instead of decimals, we want to do degrees, minutes, and seconds because that's what you measured everything in. We are good here with these other options. And I'm going to say apply, and then I'm going to say okay and come back to my drawing. The next thing I'm going to do is come down here at the bottom, these three little lines. This is my customization. I'm going to click on this. This gives me a lot of options for things I can turn off and on. You want to verify at the very top that coordinates has a checkbox. You can see the coordinates right down here in the middle of your screen. We want to know where we are today, and we care about coordinates. Last but not least, I want to remind you of your ortho snap, and I want to remind you of your other snaps, and we will be using those today. So last thing we're going to do is under layer properties, we are going to create two layers. I am going to click here to create a new layer. You know how to create a new layer. Excuse me, that is not create a new layer. That is make this layer current. So over here, we're going to come to the little star to make a new layer. And I want you to make two layers. We want to make one called BM for benchmark. And we want to make another one called traverse. And I want to give them different colors. Benchmark, I'll make yellow. Why not? Yellow's sort of bad. Let's make it green. Blue. Traverse, I am going to make my traverse. Let's go with a nice pink. Why not? So pick different colors so that you can see these lines. You are now ready to start drawing. We want to draw a line first from our benchmark layer that represents the locations of the Colton Chapel Spire and our Centennial benchmark. And so in the write-up and in the lab, I give you those coordinates. You're going to want to look at those. And as a reminder, we're working in survey feet. So there's always a couple of options, and double check you want to find the information that pertains to survey feet. And I'm going to, with that information, draw a line between the Colton Chapel Spire and Centennial, or vice versa. To do that, I'm going to draw a line using something a little bit different today. Those points are what we call northing and easting. Sometimes we're given locations in latitude and longitude. In surveying, we often refer to things in northing and easting. So I'm going to go down and I'm going to say create line by northing and easting. It's very similar to create grid by grid northing, grid easting. You could use either of these for the purposes of today, but I'm going to click on this one. And it's going to ask me for everything I need. So it starts by saying, give me the northing. I'm going to start with Centennial, where the north coordinate, and again, I encourage you to find this value so you're not like trying to see how tiny this is, 507.214.45, enter. And then it asks me for the easting, 2673.119.33, enter. Well, where is that point? I'm going to say top, and it should take me roughly to that location. Now, but we only have one point. We don't have a line. So now we want to enter Centennial's coordinates, 507.194.31, enter, and the easting, 2672 995.50, enter. All right, now I'm going to escape. It's still trying to draw a line. That's totally okay. I'm going to hit escape again, and then I'm going to hit top. And this line represents the locations. I'm going to detext just so I have this labeled. Specify start point. I don't know what the height is for here. Let's go 20. And if it looks horrible, we'll figure it out. Rotation angle is 0. Whoa, way too big, but that's okay. This is the benchmark. So let me try to do that again. I'm gonna erase that detext, specify start point. Let's go here. My height is 1, 0, benchmark. You can make it bigger, whatever you want. I just want a little reminder there, and I'm going to space bar to draw that again. And this is CC, oh, crap, I was not following the guide. Specify my start point, specify my height, specify rotation angle, CC Spire, enter, escape. Okay, so your line should look like this. If your line doesn't look like this, it means you entered a value in wrong. So now we have this line drawn. We want to draw your traverse. So we are going to eventually align our traverse with these two known points, but we don't know the azimuth or bearing of the line between your benchmark and your initial turning point. So we have to find that. I'm going to go up here and I'm going to save early, save often. And I am going to change my line to, excuse me, my layer to traverse. So because I don't know that angle, I am going to use the benchmark and the Colton Chapel Spire, which you have referenced multiple times in your survey, to rotate this traverse into place. What we're going to do is we're going to start assuming that the benchmark to TP1 is due south. That isn't right, but that's okay. We are going to draw a line. It's going to start on the benchmark. And as a reminder, if it's not zooming in, you can click on your snaps and you can select different things to help you align specifically with different points. So I'm specifying my first point, and then I have turned on ortho, so I'm going exactly due south. And I don't have real numbers, so I'm fudging them. So I'm going to say, this is where you want your horizontal distances, your horizontal angles. I'm going to say this is 100.45 due south. So that gets me from the benchmark to TP1. I'm going to hit escape. And now I'm going to turn off ortho down here. As a reminder, ortho keeps you to 90, 0 degrees, 90 degrees, 180 degrees, or 270 degrees. Instead, I'm going to do what you all did for your last homework, where I am going to create a line by angle. I have horizontal angles from each TP, backsighting a certain point and rotating clockwise to the next point. So as a reminder, this would be my horizontal angle between TP1, backsighting the benchmark, and foresighting TP2. So in this case, I am going to select my first line point. I got to tell it what is my 0 point. So I'm clicking on the benchmark, and then I am specifying my angle. And you can see it shows up in degrees, minutes, and seconds. You can type in this angle as a reminder. So mine, I'm going to try to rotate around to here. So I'm going to call mine 267.45. Okay, now the angle is locked in. You need to specify the distance. So this is your next horizontal distance between TP1 and TP2. This is 150.451. Enter. All right. You are going to continue proceeding around. So now you are backsighting TP1, you are foresighting TP3, and you have an angle. You can keep entering this angle. So I'm going to call this 227-14-53, and the distance is 70.591. Okay. I am going to keep adding my angles. So I've got an angle of 284, 284, 16, 17, and a distance of 145.612. Again, I am making this up. I've got a final angle, well, another angle of 290, 52, 0, and a distance of 100.764. And my last angle, again, turn off snaps for your last angle is my encouragement so that it doesn't zoom in on that. My last angle is 265 point, or excuse me, dash 58 dash 29, enter. My distance, 94.801. Okay. Escape, escape. You have now drawn your traverse. So you're going to want to label each one of your TPs, and you're going to want to extract your linear misclosure. How do you do this? If you go to the Analyze tab, you're going to see over here on the right-hand side a bunch of little rulers. That should tell you, oh, that's a measurement. If I click on this distance measurement, I'm going to turn my snaps back on and click on my starting and ending point where my traverse is closed, it is going to give me my linear misclosure, 2.3042 feet. Because now we know we are in feet. That is your linear misclosure. All right, so you have your traverse drawn, but how do we rotate it into place? This is where you want to use your lines associated with your measurements to Colton Chapel. So I'm going to stay in traverse, but you may want to change these lines eventually. You're going to go to, again, create line by angle. Wherever points you cited the Colton Chapel spire. So I'm going to pretend that I cited it from TP1, TP2, TP3. So I'm going to click on TP3. I'm going to specify my endpoint as the 0 line. And I am going to indicate that I measured this at an angle of 304, 312. But you didn't get a distance. So you're probably like, what is that distance supposed to be? All we want to do is project that line out far. We don't have a distance, and that's okay. I'm going to say escape. All right. The other place I cited it, so I've got TP1, TP2, TP3. I also cited it from TP4. So I'm going to hit space again to bring back that command. Oh, it doesn't like that. That's fine. So I'm going to go line by angle. So from TP4, I back-cited TP3, and I have that angle, whatever your angle was that you measured, mine I'm pretending is 332, 24, 16, enter. And again, I'm going to project that out far. Doesn't matter. So if these lines confuse you because of their color, you might want to change what layer they are on. I'd encourage you to change the color of the line type, make a new layer, do something to highlight them. But now we have a traverse. So what this traverse is saying is if you have done this perfectly, the Colton Chapel spire should be at the intersection of your two lines represented by those horizontal angles. But they're not aligned with the Colton Chapel spire, so how do I do that? I'm going to rotate my entire traverse into place. To do that, you want to select all of the lines except for your blue line, and you are going to use the rotate feature up here under the home menu. So I'm going to click rotate. The first thing it asks me for is a base point. This is where we're going to rotate around or about, and that is going to be our benchmark. So I'm going to click the benchmark, and it gets a little funky. And so if you're running into issues and it's jumping around like this, come down here and turn snaps off. Now you should have a much smoother ability to rotate this into place. And when it looks like that intersection is as close as possible to the Colton Chapel spire, you are going to click again. So you are manually finding that angle that minimizes the distance between your intersection and the Colton Chapel spire. Will they perfectly align? Maybe, maybe not. Every year there's a lot of variability, and that is okay. Your last error measurement you're going to report in your report is how far off we are from that Colton Chapel spire. So again, you can go to Analyze, and I'm going to turn my snaps back on, and I can measure that distance. 4.1005 feet is not bad. You're going to want to write that down because that will go in your report. From here, I would encourage you to nicely label everything, make it look really nice, and change some layer properties. Make this look good, like impress me. If the text is too small, make it bigger. Remember, you have lots of things that you have learned how to do. Again, I'm going to save this. All right, so last but not least, like this line is really long right now. I could make it shorter. So if I don't like that, I'm going to go here. I'm going to click on that line and I'm going to bring it back in. Yeah. Okay. Oh, that might have messed it up. Last thing you are going to do is coordinates. So we're turning on our snaps. Make sure your snaps are on. And we want to go over to the home menu. And something you probably have not noticed before is this little menu called points. And we're going to start using this for this project and for our next project where you're going to be making a map around a campus building. So we have point creation tools. We're going to click on that, and that brings up this little menu. This is going to let us create points manually. So over here, if I hover, oh, it says I can create points manually. I could also create points other ways, but I don't need to do that. So what I want to do is we're going to start with Centennial, the benchmark. I'm going to click this point. I'm going to enter a point description, BM, and I'm going to specify my point elevation, 348.94. All right. As soon as the little red X shows up, that means it has your point. I'm going to go over here to TP1. I'm going to click. It's going to ask me for a point description, TP1. You're going to specify your point elevation, whatever it is. As soon as we get the red, it means we are good to go. I'm going to come over here. I'm actually going to use the first measurement at TP2 or whatever point your traverse closes on. You don't need to grab that second location. We're going to use the first one. Again, point description, TP2, elevation. And you're going to proceed onward with each point entering the information associated with those points. So I'm just going to make this up, TP3. You can fast forward through this if you want, but I want to show you what it gives me at the end. Okay. And description, TP4, 359.333. Okay. TP5, 349.607. Cool. All right. When I've entered all my points, I'm going to say escape. All right. Now I want to know the actual locations of those points. Because I have correctly rotated my traverse into place, and everything is relative to the benchmark and the Colton Chapel spire, I now have coordinates at these points. I'm going to close this menu down. I'm going to save, and I'm going to go over here to Prospector. And if I click on points, what you should see down here are the eastings and northings for each of your points. So you are going to want to enter these points into Excel to bring into your report. So you now have coordinates, you have all of the information that you need to report error for your linear misclosure and your distance from the Colton Chapel Spire. You are going to make this into a nice map. I would ask one member of your group to focus on that. At this point, you are going to turn in your traverse drawing. So I'm going to save this. And I want to remind you of how to print. So I'm going to go up here to export or plot. You are going to select AutoCAD PDF high quality. We can keep this actually as an 8.5 by 11. That's totally fine. I'm going to say fit to paper. I am going to say extents. I'm going to say center the plot, and I'm going to say preview. And your traverse should appear right here. This is a great way to export your PDF and save it to your desktop. So if I click here, I can now navigate to my desktop, find my project 1 folder, and Kelleher Traverse, save. All right. My encouragement, so everybody needs to do this. You're only uploading that PDF, that's all I need. But I would encourage you to make sure that you all have a group folder where everybody can upload the DWGs of your traverse. You now have the rest of the time to work on your report. Way to go and have fun.